All right, so we have a few examples here of how we can apply the law of cosines. Our first one has a parallelogram with sides 28 and 40, and it gives us the size of the larger angle, 100 degrees. They want us to find the length of the shorter diagonal. All right, so I've labeled my diagram. I have sides 40 and 40, 28, 28. I've got my large angle right here. And we have to remember we have two diagonals. We have this longer diagonal and a shorter diagonal. Please remember, if we do have a parallelogram, this diagonal will not bisect this angle. Instead, we need to remember properties of parallelograms and parallel lines, that same side interior angles will be supplementary. So if I know this angle is 100, I know the one next to it will be 80. Now I can draw my shorter diagonal. And this is the length I'm trying to find. Okay, which comes down to looking at this triangle. If we draw this separately, the information I need is simply 28, 40, and 80 for the degrees. And we're trying to find the length of the shorter diagonal here. So we can see it's an SAS situation, which we use law of cosines. All right, so I've already got this set up over here. We're going to use for the diagonal x, let me change my diagram to label the diagonal as x. We have x squared equals the sum of the squares of the other two sides minus 2 times 28 times 40 times cosine of the included angle. Now I'm fine if you just show this setup on your paper. Just be careful plugging this into your calculator and remember to take the square root. Or if you prefer to write down all of the intermediate values along the way, feel free. I just kind of jump straight to this step sometimes. And make sure you're always stating your answer accurate to 3 decimal places. There we go. So right here. All right, so it comes down to just drawing a real accurate diagram and figuring out if we're using law of cosines, and whether that's an SAS or SSS situation. All right, so we've got a second example, a little more interesting. We have two planes leaving the same airport at the same time. One flies at 20 degrees east of north at 500 miles per hour. And the second one is going to be flying 30 degrees east of south at 600 miles per hour. How far apart are the planes after 2 hours? So whenever we're talking about direction, it's really helpful to draw your axes, your north, south, east, west, and the planes will be leaving from the same location here. Now, when I describe 20 degrees east of north, imagine the plane going north, and it's just going east 20 degrees, so essentially in this direction, east of north. So northeast at 20 degrees. So we want to label that in this direction, 20 degrees. Okay. Now the second plane states that it's flying 30 degrees east of south. So here's south, basically east by 30 degrees. There's my 30-degree angle. We want to know what is the distance between these two planes, this distance right here, after 2 hours. Okay, so we can see by our nicely drawn diagram, north to south creates a 180 degrees, so we can find this missing angle right here by taking 180 minus 20 minus 30. So we'll have a 130-degree angle created right here. So I'm going to redraw this triangle so it looks a little less confusing. So we have 130 degrees. This is the distance I'm trying to find. And we know in 2 hours, it gives us the miles per hour each plane is going. The first plane was going 500 miles per hour, so we can take 500 miles times 2 hours. After 2 hours, it will be flying 1,000 miles. So this distance is actually 1,000 miles. Whereas the second plane went 600 miles per hour for 2 hours, so we can take 600 miles per hour times 2 hours. It actually traveled 1,200 miles. Okay. So again, we see we have an SAS situation, and we can apply our law of cosines. So we can write d squared equals 1,000 squared plus 1,200 squared minus 2 times 1,000 times 1,200 times cosine of 130. All right, and plugging this into our calculator, we'll get d squared equals 3982690.263. Remember to keep that accurate in your calculator. Take the square root of that and keep your accuracy to 3 decimal places, in which you should get 1,995.667 miles. All right, so feel free to check these out or other videos that I've linked on the calendar for additional help.